Alright, this video is about math review, and I know you're probably groaning to yourself, why are we doing a math review if I'm in physical science? And that is because physics and math are very, very closely related. If you don't understand the math, you won't understand the science very well. So I want to just make sure, since we're going to be testing on Newton's second law, that we understand the math behind that. So let's go ahead and get started here. So I'm going to get rid of this beautiful title. And the reason we're doing this review with the background of a beautiful lake is just so you guys get relaxed, because I know as soon as people see math or have to do math, they freak out. So next time, maybe when we're on the test that we're doing math, you can think of this beautiful scenery and realize that, hey, I've seen the video, everything's going to be fine. The biggest thing that you're going to be tested on probably will be, Newton's second law, which is force equals mass times acceleration. And before I even get started on how you do problems with force equals mass times acceleration, I want you guys to understand exactly what these different parts are. So before we get any information, these are all variables. So a variable is like a placeholder for a number. So it's the same thing as just saying, let's say that this f, we can think of it, since it's a placeholder for a number, we can think of it as just being a question mark. And then let's think of this m right here. This is also a variable. It's a letter. You can just think of it as another question mark. And then let's see, let's get a different color here. Let's get a beautiful purple going. Let's have this purple, and we'll say this is another question mark, since it's a letter. So we have question mark equals question mark times question mark. Is when you get force equals mass times acceleration, that's what you should be seeing, is I have all these unknowns. But that's great. Don't get freaked out by this. I'm just trying to let you understand what a variable is. So one thing to understand about variables is that you can manipulate them just as numbers. So what that means is, how can I manipulate things? If we have this equal sign right here, this equal sign, that means that force equals some number times some other number. And what can you do with that? Well, let's say I wanted to know what m is. I wanted to know what this question mark was. I could easily do that by just rearranging, using the mathematics, and getting the answer. So how could you do that? Well, if you understand that these are variables, and you know that variables act like numbers and they can be moved around like numbers, you can just think, well, what happens if I divide this side by a over here? If I divide this side by a, you have a up here divided by itself. And any number divided by itself is just going to be a 1. So I'm going to erase this really quick. I'm just going to say, hey, that's the same thing as just putting a 1 over here. And make sure, if you divide this side by a, you do the same thing to the other side. Because if you think of this equal sign in mathematics is like a balance. So I'll go back a couple of steps so I can make sure that's clear. We have force right here equals mass times acceleration. So if I divide this side by a, I have to divide this side by a, because this is a balance. And if I do something to this side, I have to make sure I do the same thing to this side. So again, we can get that a divided by a is 1. And that's not too hard to think about. Think about any number. 2 divided by 2, it's 1. 3 divided by 3, it's 1. It's the same thing with variables. So it's the same as writing m times 1. And anything times 1 is just itself, so we don't even write that. So now we have this beautiful f over a equals m. So if I wanted to find what this m was, and I had the force and the acceleration, I could just plug those numbers in. So if you wanted to think the same way, hey, how could I get the acceleration on this other side? So since these variables are just like numbers, hey, I can do the same trick I did with a. So if I wanted to get this acceleration alone this time, let's say I wanted to get a alone. I'm trying to solve for a. The question says, what is the acceleration? I want to get this a alone. So in order to do that, all you have to do is just say, I can divide both sides here by m, and you have to do it, if you do it to this side, you have to do it to this side as well, because this equal sign is like a balance. If I do something to this side, I have to make sure to do the same thing to this side. So if I do that, it's the same thing happens. These cancel out, or m divided by m, you can think of it as being anything divided by itself is just going to be a 1. So I have 1 times an A. So if you think of that as being anything times 1, you can just write it, get rid of this 1 since it's just going to be itself. So you get, and I'll write this so it's a little closer over here. There we go. So we have F divided by M equals A. And we did this simply by just using division and multiplication and understanding that these variables or placeholders for numbers act the same way as regular numbers do. Alright, so now let's think of a little problem here. Let's think of this problem right here. This is just a normal, easy, typical Newton's second law question where we're going to use what we just learned, F equals M times A. And whenever we get a problem like this, it's important, that's why I've been giving you those sheets that help you do this, is to identify what you know and what you need to know. So everything I know in this problem, if I read it, it says Jimmy and his skateboard have a mass of 80 kilograms. If he is pushed with 10 newtons of force, how fast will he accelerate? So what do I know here? So after reading that, I know what my mass is right here. My mass is 80 kilograms. And that's just one of these variables right here. So I just filled in one of the question marks. Now it asks me what is the, and then the next sentence says if he is pushed with 10 newtons of force, so I just gave you the force, so go ahead and highlight that and think of that, hey, that's my other variable right here, I just filled in another question mark. And then if he is pushed with 10 newtons of force, how fast will he accelerate? So I am trying to find the acceleration. So if you think of it in terms of what we just talked about, this is what we're going to want to solve for because that is still unknown, or it's still a question mark. That A is the same thing as saying, hey, that's a variable or a question mark. So if now that we have identified the important information, let's just go back to the nice, beautiful, serene nature here. And now let's just solve this. Let's, relax and plug in some numbers and everything will work out. So we know that our force here, our force, if you remember, was from the problem was 10 newtons. So our force equals 10 newtons and our mass was 80 kilograms. 80 kilograms. So if we just plug these numbers, what we know, these are our knowns, into Newton's second law, the equation for that, we'd have 10 newtons equals 80 kilograms times this unknown. So now this should be a lot easier now that you understand what a variable is. It's an unknown. So let's think about this. How would we do this? We have 10 newtons over here equals 80 kilograms, that's a mass, that's how much stuff, times how much it's accelerating. So is it speeding up, slowing down, or turning? And in order to figure this out, all we have to do is we have a number times a variable. So if we wanted to get the variable alone, anytime we have a multiplication, we do the opposite. So if I want to get the A alone, if I want to isolate the A, we can divide both sides by 80 kilograms. 80 kilograms. If we divide both sides by 80 kilograms, just to keep that scale balanced, so the scale side of the scale is balanced with this side, and that's what we need to know for that equal sign to be true. You can just think, hey, I'm going to cancel these out, meaning 80 kilograms divided by 80 kilograms, that's the same thing as just writing 1 times A, because anything divided by itself is going to give us a nice, clean 1. And if we have 1 times a variable, we know that, hey, that's the same thing as just writing it as A. So I'm going to move it a little closer so it's a little clearer. So we know now that A, this acceleration, is equal to 10 newtons of force divided by 80 kilograms of mass. And then from there, you can just plug that into your calculator and see that 10 divided by 80 is the same thing. If we simplified that, it's equal to 1/8, and that's also equal to 0.125. And now I'm not going to talk about the units because I did that in the free fall, but newtons divided by kilograms, that's going to give us meters per second squared, which is the correct units for acceleration. Remember, it's the rate change of velocity. So it's going to be meters per second squared. And that's just because a Newton is a kilogram times meters per second squared. So the same reason that the variables cancel, the units cancel, and that's going to leave us with this nice meters per second squared, which is the same thing we get over here. So acceleration here equals 0.125. Hopefully that cleared up any misconceptions about how to do the math. If you have any more questions, feel free to ask. Don't get freaked out with the math. Don't get freaked out about the letters. Hey, those are the same thing as just putting question marks. So on the test, just a reminder, when you get one of these problems, relax, take a deep breath, and just remember the beautiful surrounding, and you'll be fine.